Okay, this video is going to be a combustion analysis problem. So you remember in class that we did 51B together. So 51A is going to be the problem that I'm going to solve here. 51A, however, only deals with a hydrocarbon, meaning we're only looking for an empirical formula that just has carbon and hydrogen in it. So we're not going to have to do the subtracting to find oxygen, or if there was something else in it like maybe nitrogen. Hint, hint, maybe for your test. But in this case, we're just dealing with a molecule that has carbon and hydrogen in it. So if you read the problem states you're solving for the empirical formula of toluene. Toluene is a hydrocarbon, and then it tells you that the combustion analysis information that you get is you have 5.86 milligrams of carbon dioxide, and you have 1.37 milligrams of H2O. So since this is toluene and it's saying that it only contains hydrogen and carbon, we only have to do two different conversions here. Now the difference with this problem is we don't have to convert all the way to grams, because most of the time you're subtracting to figure out oxygen, and that's why we convert to grams. But in this case, we don't have to do that, right? Because we don't have a starting mass, and we're just solving for something that has just carbon and hydrogen in it. Okay, so the first thing that you have to do is you can either do a conversion to convert from milli to grams, or you can just swoop 3 times to make it grams. So that's what I'm going to do. I'm just going to say 1, 2, 3. So this grams will be 0.00586 grams of carbon dioxide, where this one would be 1, 2, 3. So this one would be 0.00137 grams of water. Okay, now in order to solve for empirical formula, you need moles. We already have grams, right? So I went percent to grams. Grams is already given to me, so now I only have to do grams to moles, okay? So my question mark moles here is going to be carbon for my first one, and it's going to be 0.00586 grams of CO2, right? So my first conversion is going to be for every 44.01 grams of CO2, I have 1 mole of CO2, right? And for every 1 mole of CO2, I have 1 mole of carbon, okay? So if I was to calculate this problem, or this number, so let me do that. So I'm doing 0.00586 divided by 44.01. Oops, I messed that up. 0.00586 divided by 44.01, and I get this number, 0.000133315, but I need 3 sig figs, so it's going to be 0.000133 moles of carbon, okay? Now since I'm solving for empirical, I have to keep going, and I have to solve for hydrogen here, right? So I'm going to say question mark, moles of hydrogen is equal to 0.00137 grams of hydrogen, or of water, right? So I'm going to go for every 18.02 grams of water, I'll have 1 mole of water. And then for every 1 mole of water, I'll have 2 moles of hydrogen, right? So now I can solve for that. So I'm going to do 0.00137 divided by 18.02 times 2, and I get, with 3 sig figs, 0.000152 moles of hydrogen. Okay, next step, divide by the smallest. Okay, so here, if we look at this, my carbon is going to be the smallest guy here, right? 0.00133 is smaller, so I'm going to go divide this by 0.00133. So up here, this is going to be 1, and down here, this is going to be 0.000152 divided by 0.000133, and I get 1.14 Okay, now this is kind of funny, all right? This 0.14 cannot be ignored, okay? So I can't say that my empirical formula is C1H1. Okay, one way to figure out what do I multiply this by. So 0.3 is easy because we just multiply it by 3, right? 0.5 is easy because we just multiply it by 2, because that's half. Okay, so a little trick here, you can say, okay, what if I had 100 of something, right, and I divide it by 0.14. So I'm going to go 100 divided by 14, and I get 7.14, which means if I was to multiply this value right here by 7, I should get something close to a whole number. So let me see if I do. 1.14 times 7. What do I get? 8. Good. So that's better. That's a better, closer to a whole number. So this will be H8. And if you remember, whatever I do to one of my elements, I have to do to the other one. So I have to do times 7 up here. So the empirical formula for this combustion reaction will be C7H8. Okay? And that's the empirical formula for toluene. So that's number 51A. Let me know if you have any questions.